DIY 1978 guy back with another video. Finally, it's been a hot minute since I've been able to get a video done. Man, I've been busy, life's been busy, activities going on. The weather has been completely just, Mother Nature's been off her meds. You hear me talk about weather all the time every time I get on these videos. So it wouldn't be the proper DIY video if I didn't start off by talking about the weather. But the weather has just been absolutely ridiculous. Cold one day, warm the next, raining this time, not raining that time. And then, of course, we got this past weekend, we had daylight savings time, which is supposed to give us a little extra daylight. So we'll see how that goes. Maybe that'll help me get some more content out. But either way, I still thank you guys all for, the message you send, the comments y'all send to my page. Try to get a little bit of content here and there on my Facebook page. But anyway, let's jump into what we're doing today. I'm glad to be back. Glad to be back in providing some more content. Hopefully you guys enjoy this. A little bit different today. We're working on an electrical problem. Not a big electrical problem. Pardon me, my nose is itching. It's allergy season. The pollen is on point. I mean, it's everything my allergy medicine can do to stave it off. So if I start sneezing, coughing, pass out, don't worry, I'll get back up, something like that, whatever. Anyway, I digress. Also, I'm trying out yet another new microphone, which so far seems to be working a lot better than that previously piece of junk one that I had. And if this works good, I'll put it down in the comment section or the description so you can see which one I've got in case you want to try and do it as well. And this new microphone, I love it. Also, I bought a new stand and everything that I'm using that also came with a handy dandy little remote so I can control the camera. Very good. We're still using my phone. Still having issues with the GoPro. One day we'll get that sorted out, but not today. Anyway, back to the subject at hand, or the Patient. The Patient is a 1996 Champion bass boat. I believe it's a 20-foot. It's my father's bass boat. He's had this thing for many, many, many years. I mean, heck, the thing is considered an antique, but it's got the 150 horsepower Mariner motor on the back, which you can't see in this view at the moment, but that's irrelevant. We don't need to worry about that. But anyway, awesome boat. I take it out on the lake, on the river. Sometimes we go ride and everything like this. I go fishing with my dad. He takes it up to the can. Trailers this thing all over the place to go fishing and go boat riding. Well, like anything else, the more age you get on it, the more you're going to run into issues. And this one has a little minor electrical issue that we're working through. So I'll take you in there and show you what's going on in a minute. But essentially, his front depth finder, he got a new fancy depth finder that he's got up in the front, fish finder type of thing, whatever. Anyway, it's got a wire that's just hardwired up from underneath the dash under there. Again, I'll show you all this, but hardwired up to the front there to power that thing up. Problem is, you power it up, comes on, screen starts flashing, starts giving a low voltage warning and everything like this. So the battery voltage in there is fine. There's no issues with that. So that's what I'm running through today, is trying to figure out where the voltage drop is occurring and why, and then see if we can get that rectified so that we can actually use it to find the fish. Because I don't know about you, but if you fish, hopefully you have more luck than I do, because my fishing goes about as good as, well, my dating life does. So, and, which is dead and gone. Every time I fish, I'm lucky if I catch something. But, and I've been doing it for years, which is sad. I don't know. Maybe I'm just fishing the wrong places. But if you have fishing, if you have any bass fishing recommendations and everything like that, by all means, I'm all ears, because my red shad worm, which used to be the thing I go to, just doesn't cut it for me anymore. Anyway, let's take a look at what's going on in there. I'm going to pause this a minute, and I'll go bring you over there and show you what it is we're dealing with. So stay tuned. Okay, so here we are back on. So this is what we got. So I got a new Lowrance Hook Reveal 7SS depth finder, which is currently off. Like I said, there is a hard wire that just comes all the way up from the dash up there, comes running all the way up here, goes into these two little bullet connectors right here, which are not the most seamless crimps. I do see some bare wire back there that I'm going to have to fix, but that actually I don't think is the problem right now. So we have 2 voltmeters. One of them's under the dash right now. One of them is up here. And as you can see on this extremely delicate screen, or delicate's probably not the right word. Going out would probably be the better word. 12.8 volts is what we have coming up here from the battery in the back. And when you power this thing on, hey, look, there's my reflection. Power this thing on, instantly you can see the voltage just drops. Okay. And as this thing powers up, we'll start getting some screen flashing. There was a little one right there. This thing takes 3 years to boot up. Maybe I'll go get a coffee and take a nap, or take a nap then have coffee. There you go. You see, as this thing boots up, the voltage just drops. 11.5, 11.4. There's the beep. See, we didn't even get to the low voltage yet. That's the low voltage beep. There it is. Less than 11 volts. Now, that's a little bit inaccurate. There goes the screen flashing. Either that or Big Brother's got a hold of it and is taking pictures of me too. But you can see we're not below 11 volts, but we're in the neighborhood. So, and like I said, I also have my meter under the dash where this wire comes in. So we follow this all the way up here. And then down here, I've also got my meter on the wires underneath the dash, which has turned itself off because it's been sitting here so long. So let me power that back up. Put that on direct current. And there you go. So we have the same voltage here at the source as we do up front. So something is amiss up under here, and that's basically what we're working with right now and what I'm trying to do. So I did do a little bit of a head work, just to try to figure out what was going on, but that's essentially what we're working with. So give me a couple of minutes to kind of get through this, and we will see if I can get the next step in the process here as to where we're actually going to have a problem. So stand by. I'll be back. All right. Man, so getting this camera angle set up under here was kind of a pain. Good Lord. Anyway, so as I stated, these are the wires that feed that depth finder right there. We got a little fuse holder on here, ground wire coming in. As I said, I got 11.1 volts and basically 11.05 up there at the meter that is showing. So this is also another power source that we have here. And these connections, they're old and a little crusty, but they, for the low voltage that thing is drawing, should not be a big problem. So I'm going to go ahead and actually swap this over and test it on the other wires to see if it's something particular to these cables right here. So let's go ahead and pull out these, black to black, right there, and red to orange. Plug that in there, and then we'll put the meter in the back of these. See what we get. All right. Right now, you can see that it's showing 12.6 volts, but of course the depth finder's off. And the meter up front is showing 12.6. So let me go ahead and turn that thing on and see what we're getting over here. Power on. All right, this meter up here is dropping to 12.05 so far. And see if I can set that where I can see it. And as we were watching, 12.01, 12.0, so these are pretty consistent, 11.7, 11.6 up front. These are pretty much the same. 11.6, 11.3, 11.5 in the front. And the screen on the depth finder's flashing a little bit here. Wonder if I can hang this over here so you guys can watch this. You might be able to hear that beeping up there. That is the depth finder. Can you see that? Probably not, huh? So low voltage alarm. I got 11.3 here and 11.25, 11.3 up front. So pretty consistent. So the issue does not seem to be particularly with these wires. My suspicion is there's a bad ground somewhere. So basically what I'm going to have to do is I'm sure you get a nice washout from the sun. I'm actually going to have to try to trace these wires under here and find out where they go so then I can determine where the ground is and everything like that. Now, as a test, I'm going to take a piece of wire. I'm going to run it directly off the battery, bring it up front and connect it, and make sure that we don't have something wrong with the depth finder itself. So basically bypassing the wiring in the boat. So let me wire that all up and then we'll test it again and see what we get. So stand by. I'll be right back. All right, welcome back. So I got me some wire here. It's a long piece of stranded wire that's already put together. Helps that it's already red and black, which makes it nice. We got our 840 piece mixed terminal set, which we'll use, and of course connectors, or excuse me, clip assortment here. So let's go ahead and see what we can do with this. What do we want to do? We want let's see, which clamps do we want? We'll just use these. Use a little metal ones. Make it easy, right? Bop. And bop. Boom, boom. All right, so up here on this, we've got we got two bullet connectors here. So they are actually the same. They're female on the depth finder side and male on this side. Generally, I like to make them opposite so that you don't accidentally plug them in the wrong way. But I suppose putting it that way also makes it. Oh, look at that! As I'm pulling it, the wire just came apart. That very well may actually be the problem right there. So very interesting. But what I was about to say is a lot of times it's better to put the female end on the side that's supplying the power, so that if they're unplugged, you don't accidentally arc it out to ground. So let me go ahead and get my new wire made up here, and of course I'll have to fix that too. So like I said, that might actually be the problem. So we are going to use the 1622 gauge bullets, which I think will actually fit right into the back of that thing. So go ahead and strip this back. You guys see me do wiring a couple times. I don't have one of those fancy wire stripping dealy bobs, but also don't need it because, for all the years I did car stereo work, just learned that you take your crimp connectors, you just cut around the insulation and pop, you can pop it off. So let's put this on here. I know this is probably like watching paint dry, I'm sure, right? So there we go, two bullet connectors on the end. I am gonna crimp these down just a little bit, just to make them a little tighter so that they hold on to the bullets a little bit better. There. So where the hell's there we go. There's a viewfinder. So I gotta actually, like I said, crimp this down just a little bit, and then squeeze that in. And basically what I'm doing is just making the hole a little bit smaller so that when I insert the bullet, it stays. That's it. That's all I'm doing. Tricks of the trade, tricks of the trade, tricks of the trade. So, how's the weather where you guys are? Actually, leave in the comments where you hail from. I know where some of the people are, obviously, because they're close to me or they're friends of mine. But I don't know actually where everybody's from who follows my page here. So be interesting to know, what demographic you're in, what area you're in, and so put that down in the comments and let me know. So, of course, as you guys know from me, I'm from South Louisiana, and been here just made 32 years in December that I've been back here. So I was actually born here, and then I lived up north for 10 years. Don't really miss that, I'll be honest with you. Not much of a cold weather person. So, all right, so there you go. So we got our clips on the end. These are going to go on the batteries. These are going to go onto the depth finder. Now, as stated, sorry for the shaking. I also got to fix the wiring for the depth finder. You can see that that is not that great either. So I also just go ahead and put new bullet connectors on both of these. So if I remember correctly, I think this was done, whoever did it, I think they were doing it in a hurry. I don't recall the reason why, but we'll just chop that off. And I'm actually just going to take the tape back on this thing and see. Let's see what's actually under here. I mean, they use electrical tape, which is good, Like I said, I always use it to... There we go. All right. So we got hot and cold wire. Best you can guess which ones are which. As you can see, this thing should not be drawing that much current. I mean, we're talking like this is 24 gauge wire. I mean, this wire is tiny, so there's no reason why the voltage draw should be the problem here. So I go ahead and strip off a little bit more. I'm gonna show you another trick that I do too, because sometimes these connectors, I mean, you're talking about a wire that small, it's hard to get a good crimp on them. So where's my bullet connectors? Here we go. I mean, these are, like I said, these go from 16 to 22 gauge. That's awful thin. Yeah, you could crimp down onto that. So what I do actually is I will actually take the wires while I strip a little bit back, and I'll fold it into a little U and then put the connector on. It gives it a little bit more surface to bite on and helps it to not pull out the way that one just did. So let's see here. It's good. And I'll do the same thing with this one. Fold it into a U, put the connector on. I wish I had black and red for these, that'd be nice, but I don't. These are just color coded by the type and size of wire that they take. So there you go. 2 new bullet connectors. So let's go ahead, and I'm going to kill the power over here so that we don't have any power. So I'm going to go ahead and connect my power cables here. So we got black to red, red to black. Just kidding. Black to black and red to red. Right? Y'all check my wiring. Is that good? That looks right. Okay. I'll wrap that around there. And I'm going to go connect this to the battery back here. Let's see here. Oh, lean over the front of the boat here, or the back of the boat. How's my microphone sound way over here? Pretty good? Guess we'll find out in the final cut. All right, so we're connected. Black to black, red to red. And let's go ahead and watch the voltage on this thing and get my meter connected. There we go. All right, 12.77. Survey says. Let's watch it and see what happens. Here, I'll see if I can blind the camera while I'm at it. All right, so we're powering up. 12.5. Doop-de-doo. Again, waiting for this thing to power up. It takes a little while. Come on. Be half a day of fishing done by the time this thing powers up. All right, accept. Loading charts. And what do we got? 12.45. And the screen is up. And let's give it a minute and we'll see if we get any low voltage alarms here. Stand up. Like Ludacris said, stand up. Stand up. Stand up. You know, while we're waiting for this thing to normalize here, you know what there's an amazing absence of? Animals running around, cicadas barking, dogs barking, people barking, four-wheelers and stuff coming by, squatted trucks making a whole bunch of noise 3 miles away, but you can hear them because their exhaust pipes are null and void. Well, their mufflers are anyway. Not a fan of the squatted trucks. If you have one, all the power to you. To each their own, but not a fan of squatted trucks. Looks like we're probably going to be good here on this voltage. All right, so what do we learn? Bypassing the boat wiring, we have good voltage. This is directly off the battery. Now, as I was stating, what did I say earlier? Bad ground. While I was pulling this wire, we saw this thing pull out. Look at this. That would happen to be the ground wire. I'm going to go ahead and reconnect now that I have good connections, good bullets on these. I'm going to reconnect and test the power on it and see what happens. So hold tight. I'll be right back, okay? Where did my... All right, welcome back. So I've got the original wiring hooked back up to the meter here, and I've got, or excuse me, to the depth finder, and I've got the meter back fed on it. Right now we're showing practically no voltage just because I have the switch off. So you go ahead and fire that up, turn the switch on, make sure we get power, which we do, right? Yep, 12.73 volts. And I think I was seeing 12.5 earlier when we were using the wiring here. So I guess now the test is going to be, let's power this on and see if we get a voltage drop. There we go. Cue the Jeopardy music. 12 point, we got 12.1. And we'll see. I'm watching it because it's backwards on the screen that I'm looking at. It'll be forward for you, but it's backwards for me. So really, I'm probably on like this side, and this is on that side, but I'm on this side now. 11.5, 11.4. Whoa, look at it. We're getting a little drop again. Let's see if that thing actually gives us a low voltage alarm again. Oh, we just said 11.1. Is it just me, or does it seem just a tick more stable than it was? 11.5. Still not the 12.7 that we were seeing, or 12.5 that we were seeing with the home run cable back to the battery. But that's, you know, that's kind of to be expected sometimes because that switch that I turned on actually powers up all the accessories and the dash and everything. So, I mean, it's possible that there would be a little bit of a voltage drop across that. But we're not getting any low voltage alarms at the moment. And what are we at? 11.5, 11.6. still not super crazy about that. I still think we should have 12 volts. Let me look and see what the meter under the dash says. Meter under the dash says 11.6 as well. Let's go measure it at the battery and see what we're showing at the battery here. At the battery, we have 12.5. Okay, so there's a little bit of a voltage drop across this wiring. Again, to be expected. I mean, but that's a 1 volt drop. That's a little bit excessive in my opinion. So I'm going to go ahead and now I'm going to replace these other connectors on the other on this wire, the male side. I'm going to replace those because those look kind of shoddy, and I'll replace the ones under the dash, clean up the terminals, and then we'll take a look and see. So stand by a minute. Let me get that taken care of. Ha! I got another test I'm going to do real quick. Since I got bullet connectors on this, let's isolate just the home run that goes up to the front there. So I went ahead and took my, can you see this? I don't know if you can see this. Where? All right. Anyway, you can't really see this that well, but I took my wire that I made with the bullets, plugged it into the wire here, and then I'm going to go ahead and plug that in to the depth finder and see if we still get the voltage drop with this cable. And this is coming from the same source up front that the original cable was. So what we're doing now, like I said, we're isolating this cable from its destination, excuse me, its source up to here. If they, just in case it's not these bullet connectors that are having the problem, if there's something in the wire run, I can always just pull that out and just put this new wire in. So let's go ahead and backfeed this to the meter and see if it wants to play nice. All right, 0 volts right now, just because I don't have the switch on. We have power. Of course not. 10 to 1, it's the ground cable. Of course, this ground cable does not want to backfeed properly. How about there? Come on, you punk. Okay, there we go. 12.74, which is consistent with what we had starting with directly from the battery. Power up. What do we drop to? 12.08. It's not looking good yet. 12 volts is still good. Oh, look out. I don't know what the heck that was. I feel a bullet hit me in the head. Maybe it was a gunshot. I don't know. 11.6. It's pretty funny while we're waiting for this to normalize. Just a few minutes ago, you heard me say there was an absence of noise out here. Oh, we got some flashing. 11.7. You heard me say there was a lack of noise out here. Literally the minute I stopped the camera, my neighbor behind me must have known that I said that, because she immediately put the little yard birds outside and the 2 little chihuahuas, and they went to barking their heads off. Fortunately, she put them back inside because she's got about as much tolerance for their barking as, well, most of us do too. So, but anyway, what we got? 11.7, 11.6. So, all right, so we're at 11.7 there. Let's see what we got on the battery again. We have 12.5. So 11.7, so that's what? That's a 7/10 drop? No. Am I doing math right? What's 12.5 minus 11.7? That's 0.8. So there you go. So 0.8 drop. It's a little bit better than what we had. Yep. And so far, no low voltage alarms either. So we do have a consistently better voltage than the 11.1 that we had before. So it does not appear that this wiring is having an issue on this side anyway. So I'm going to go ahead and replace these connectors, like I said I was going to do, and replace the ones on the other end as well. Get everything all sorted out and straight, and then we'll plug this back in. Maybe we'll do a little triage under the dash to see where the ground is for that, and maybe we can clean that up and see if we can get a little bit better. So give me a couple minutes. Let me sort this out. All right. So we've got these connectors redone here. I went ahead and put black heat shrink on the negative, yellow heat shrink on the positive, so we know which one is which. And let me go ahead and connect these to the depth finder. Snug those in. All right. So now we got to replace these other ones, and I'll take you on that journey. So here's the existing wiring. Look how nice. Isn't that special? Let's see. Just cut this tape off of here. I don't know why this wire, this red wire, is not being used, and there's this additional red wire. It seems to be maybe married in right here, but whoever did this loves them some bullet connectors. So I'm more a fan of butt connectors. There we go. See, look, got more exposed wire sticking out of here. Not a good one. So let's see. What size fuse do we have in this thing? E. Yeah. Oh, you can't see that. We got an E fuse. There you go. No matter which way you're looking at it. 3 amp fuse. Like I said, more than this thing probably even needs to draw. We're going to go ahead and just use a regular crimp connector on this. And then also on here. Now normally, if I would have seen a difference in the voltage between my, the cable I made and the one that's already in the boat, right, then I would have gone after chasing this cable down, chasing this wire down, figuring out what the heck it goes to. But because we don't actually have a difference, I'm not going to bother figuring out what this other red cable is in the wire. But on the off chance that there is power coming through it, I'm going to go ahead and cap it off. Okay, so we got that, and I'm kind of a stickler about my wires all being the same length. So let's see what we got here. These are not the same length, as you can see. So we're going to hack this off. Actually, we're going to hack these off together, and they're going to go flying. We'll put new bullets on there. Like I said, I wish I had red and black. That would be super helpful, but I don't. So I'm going to have to use, again, more of the heat shrink. I know, watching somebody do wiring, again, is like watching paint dry. But it's all in the education on how to do this, right? So the purpose of this whole expedition is to start at the front and work your way back, right? Whenever you're chasing an electrical problem, especially one like this where you have voltage drop across a circuit, you always want to start at the destination, figure out what you got, work your way back, find the next connection point, disconnect, and test there. Reconnect, test again, and see if you get the same result as you have up front, you know, at the destination. Then you basically work your way back until you find where the issue actually is, where you don't actually have the voltage drop anymore, and that's generally your area of interest. So go ahead and tape this up. I'm going to leave that sticking out of there just in case we want to tap into that one day for something. Again, not knowing where the heck it goes. Maybe it does supply power to something, who knows. Okay. Come along the black wire here. And then we'll reintroduce the red wire into the taping. And I'm just going to leave a little bit of that exposed so you can tell which one's which, instead of going for the heat shrink. But there you go. And that's what the good taping sounds like. Sounds like. Sorry, I got distracted by a message that popped up on the screen. Okay, so here we go. We're going to go ahead and plug this back in, and we're going to retest the voltage up front again to make sure that we have what we're looking for. So let me get that connected, and then we'll test it. All right, so 0 volts right now. Let's go ahead and power the switch on. And what do we got? Holy cow, we actually got a connection the first time. 12.7. So let's go ahead and power this thing on and see what we get. What are we looking at right now? 12.2. All right, not too bad. By a show of hands, how many of you out there like troubleshooting electrical stuff? Not really. I had my toes crossed. I hate troubleshooting electrical stuff, but it's a necessary evil, right? I mean, it's all part of the system. There we go. And what we got? 11.8, 11.7, 11.5, 11.87. So what do we gain? We gained an extra, looks like we might have gained an extra 1/10 of a volt. Almost 2/10. Look at that. We're at 11.85, which is very good. We had 11.1, 11.2 before. So that is an example of just how much, you know, faulty connections or bad crimp connections, things like that, can cause the voltage to really spike and cause the issue. Like I said, I think this thing's probably a little oversensitive, but being that this thing is going to operate primarily when the engine's not running, obviously if the engine's running back there, it'll be feeding voltage into the battery. I wish I could get this thing to sit up like this. There we go. Let's see. Can we get both? All right. If the engine's running, it's feeding voltage into the battery, which is going to increase the voltage at the battery 13 and a half, which then would increase the voltage up here, right? This would be 12 and change. But because this thing is obviously primarily going to be operating when the motor's off, because you're just trolling around with the trolling motor, you're going to have just the static battery power feeding this. So it looks like we were just on the threshold of what this thing is good to do. I don't know how the heck you get this thing to actually start, because it says stop. Whatever, or something. Hey, look, sweet. I don't know how you get it, but we're not getting any more flashing, and we're not getting any more voltage alarms, which is cool. And we have 11.8 volts up here, which, like I said, is more than sufficient for what this thing should require. So we might actually be at a place where we can call this good. I still don't like that there is, you know, call it 6 to 7 tenths drop from the battery through the switching assembly up to here. But I'm not unhappy with 11.8 volts up here. Just for the heck of it, I will dig around under there and see. And if I find something, I'll come back and show you, just to see, like, if I find a bad ground or a, weak ground or something like that that helps to improve the voltage up here. By all means, I'll come back and show you. So stand by for a minute. Let me dig around under there and see if I can't zap myself or pop a fuse. Thought I'd come back for a minute and show you something else that I found interesting. So the depth finder is connected to the wiring that it was meant to be connected to under here. And I told you there was an additional lead down here that it connects this surface temperature gauge in the dash, which is disconnected. So the depth finder is still on. Right now I'm showing 11.8 volts up there. Now I decided to test the power on the cable that wasn't connected, which is not part of the current draw, up to the depth finder, just to see what we had. And look at that, 11.82. So pretty much the exact same as what we have up front. So the current draw that's happening up here when we power that switch on is also affecting this part of the circuit as well. So wherever this ground goes back to probably could stand to be cleaned up. But again, I'm going to dig through a little bit. If it's easy to find, I'll find it. But again, I'm not unhappy with 11.8 volts on the meter up there. So, but I did find that interesting, because before we were testing across the circuit that was actually connected, drawing the power, which is the depth finder up there. This is a standalone set of wires that's connected to the same circuit, but not currently, with the only thing connected to it right now is just the voltmeter. So the fact that it's showing the same thing means that this entire circuit under the dash here is showing the same voltage. So interesting. I'll be right back. So interesting turn of events here. I was just getting ready to say this was completed, and I had the one up there turned on, the depth finder turned on the entire time, along with the voltmeter on there. And I just got through buttoning up all the wire under the dash here, and all of a sudden, beep, beep, beep. Stupid thing started beeping again. Voltage dropped to about 11.3, 11.2, something like that. Now, what I've determined is that it's not necessarily something under the dash, because I went through, I found where the actual connection comes in, the main harness that comes in under here that feeds power. Check the connection on the back of that. Also showing a good solid 12 volt, 11.6, 11.7. Same thing what I'm seeing on the meter up there is what I'm seeing on the main connector down here. So I don't think it's a problem with that. So just on a whim, I decided to test both of the wires under here. And what I mean by test is basically you isolate one side of the circuit. Instead of isolating the both of them like we did, we ran a new power and ground off the battery straight to it. Now what I'm doing is using the ground wire from this harness under here, but I have the home run for the 12 volt wire coming off the battery back here. I did it in the reverse, right? I did the using the power, the 12 volt source, or 11.6 in this case, the 11.6 volt source under the dash, had that connected to the boat, and then ran the home run for the ground, tested it, and I had the voltage drop again. So now I have it flipped. I have the depth finder ground plugged into the harness under the dash here, and then I have a home run running from the 12 volt side of the battery straight to the 12 volt side of the meter and depth finder up there. And wouldn't you know, 12.3 volts is what I have up there. So what does that tell us? That tells us that the 12 volt feed coming in from the boat wiring, from the battery into this harness under here, is lacking in some way, shape, or form. So I'm going to go pull that off back there, clean all that up, and reconnect it all, and then recheck it again and see if we actually get the proper voltage. If it was literally just that back there, the battery, that was the problem, I'm gonna laugh my butt off. But like I said, you start at the end, work your way back, and by process of elimination, you'll end up figuring out what the problem is. So give me a second. I'm going to go do that and see what the results are. I'll be right back. All right. So this is the battery that we are interested in. I'm going to move this out of the way. This is the battery tender. We have obviously power and ground. We have a few 12-volt leads that feed up here. Right? So we have a number of different things that feed power into the boat. One of these is the main harness feed. And I'm pretty sure it's not that one because that one's garbage. But what I'm going to do is I'm going to disconnect these and we're going to check one by one and see which one actually feeds the power up to the front. All right, so let me go check my meter here, plug my cabling back in to the factory cables. So I'm plugging the front meter back into the boat power source. So both the 12 volt and ground source for the boat, like for the boat wiring, is now feeding that, excuse me, that depth finder. So let's see which one actually supplies the voltage to the boat power. Is it this one? What do we got? Negative. Or no, positive. Not negative, but negative. So it's not this guy, right? It's not that one. Let's see what's behind door number 2. Nope, nothing. Okay, so which means it's probably this big old honking son of a gun right here. And let's see. That's the one right there. Okay, so that goes into a harness under here. So this big old thing is what actually powers the, well, you can't see that. This big old thing is what actually powers the boat accessories and everything like that, including what goes up front. Now, that's kind of a junky connection on there. Let's see what size fuse is inside this thing. Glass fuse, rusty. Okay. This is a hard to read fuse. Sorry, I got a 20 amp. Is that what that says? I don't know. Can you guys read that? What does that say? 20 amp? Yes, that is a 20 amp, 12 volt fuse. Okay, so as you can see, these connectors are a little bit cruddy too. So let's go ahead and twist this up in here. See if we can get a little better connection. There's all kind of junk coming out of this. Oh yeah, look at that. That's pretty disgusting as well. I could probably get some emery cloth and clean that up. So, but this actually will probably do good. Just gonna twist this up, basically grind that content, that stuff together, and see if we can snap this crappy fuse holder back together. You know, I might actually just change this whole fuse holder if I have another one. All right, so let's see. I'm going to connect this back to the battery, tie it down with this wing nut, And I'm going to go power up the depth finder and see if we still have 11.329er volts. Let's go see. Okay, so right now, you can't see that. We have 12.74 volts. 11.8. I'll be willing to 11.4. Yeah, still a junk connection. All right. So here's what we're going to do now. I'm going to bypass the fuse holder on that wire, and I'm going to go straight to the battery with that wire just for a second, just to see if this fuse holder is the problem. Again, process of elimination here. That's all it takes. All right, so I'm going to cut this fuse holder off. If I can find my cutters, side cutters. All right, and we're going to use my wire that I made to go directly to it. Let's cut this dang thing off. All right. I know you can't see this. I wish you could. All right. This new stand I got is not the greatest for minimal changes in height and everything like that. But, okay, so I'm going to take the red side of my alligator clip. This is going directly to there. And the other end of this, we're going to go straight to the battery. So now I should have 12 volts up front, and I do. So let's see what we have up here for voltage now. Stay. All right, 12.7. Aha. Better. Nope. See, it just dropped again. So there's clearly another electrical gremlin somewhere underneath there. It's not the fuse block, but I'm going to change it anyway. If I have one, I'm going to change it anyway. All right, so what does that mean? That means that now I got to trace that wire up towards the dash, figure out what all it goes into, and then see if there's another bad connection under there. I'd be willing to bet I'm going to find a bad connection between two pieces of wire. So let me dive through that, and I will be back when I figure out, or when I don't figure out, or when I do figure out what's going on. So be right back. So here's another interesting turn of events. I went ahead and put the original fuse holder back on, but I did go and clean it all up and everything like that. But so I decided to come up here. I couldn't trace the wire. I know it goes up into the side hull of the boat and everything. So I decided to come up here to the switch panel and catch a voltage off the back of the switch. So now, interestingly enough, off the back of the switch, I've got 11.9 volts and 11.5, 11.6 up front. But I have, if I can catch this on the other side, 11.8, 11.7. So let's see. Earlier I had an actual discrepancy across the switch, but it's looking like, get in there, looking like I don't now. Oh well. Thought I found something. So that wasn't it. Originally, when I first checked it, I had a discrepancy across the switch. I had 12.5 on one side, like 11.8 or 12 on the other side. So interesting. Guess that's not it. So back to the drawing board, one way or the other. Let me get this figured out. All right. Every good DIY guy needs a non-alcoholic brew to help clear the mind and attract the fleas. Yep, there's one flying around my head right now. Anyway, I got updates. So here's what I've got. So we have a 3rd voltmeter. Always good to have, extra stuff. Directly off the battery, we got 12.3, call it 12.35 volts. Under the dash, we have, this is coming, basically I unplugged everything under there and found the one harness that still had 12 volt power on it after I unplugged everything. We got 12.1 basically underneath the dash on this plug right here that seems to be the first plug in the chain that powers everything up. And then of course, I have that running. I have the cable for the depth finder running directly off of that as well, off that feed, and we've got 12.15 up here. So let's see. So we've got, it's fluctuating a little bit. I mean, we got what, 12.18, 12.14, which I mean, these two should be pretty much the same. And we have about a 0.2 volt drop across it. So right now, I'm assuming that that plug is in fact the main plug that feeds. All that runs up into the channel here, goes all the way back to here. I don't know, and then of course pops out inside there. I don't know if there's another connection up inside here though. That's the one thing I'm not sure of. I don't think there is. I think that feed straight off the battery, the one that I repaired, I think is the main feed for that harness under there. But I'm going to try to verify it and see. If I can verify that, I might just bypass it, see if I can pull another cable through there and see if I can get a different result down there. Because as we've seen, right, if I run something straight off the battery to there, then everything seems to have better voltage. So I'm running out of daylight over here too, so I'm going to be working under lights, as you can see, carport lights and stuff. So I'm running out of daylight here, but I'm going to continue on, and I'll come back when I have another update. So hope y'all are enjoying this so far. Be right back. All right, so the next test that we're doing to isolate this is I'm checking the resistance drop from the end of the terminal that goes on the battery, which I'll just show you. Look, here we go. So here again is the cable that feeds that harness. I'm checking the resistance drop across this entire cable up to the plug here, right? Because that's where, so basically what I'm doing is I'm confirming, one, that this is the connection that goes to the back, but two, is there some kind of a resistance drop across it? And so the way I'm doing is I tested the resistance drop across this cable because I had to use it as an extension. I had about a 0.2 ohm resistance drop or so, 0.1, 0.2, which is basically nothing. Okay, that's basically zero. You can handle a couple of ohms here and there and it won't be a big deal. So basically zero. So I ruled that out to get that as my control because I had to use that wire as an extension for my meter here. So I have, as you saw on the battery, I have one side of the meter connected to that wire, the other side of the meter connected here, and what do we have? between 0.3 and 0.5 ohms, 0.2 and 0.5 ohms, which is practically nothing. It's 500 milliohms. Again, practically nothing. Not enough to cause a significant drop of voltage across the wire. So essentially what we're looking at is, I think, for all the tests that I've been able to conduct, I'm pretty sure that this terminal and this plug here is the direct run from the battery up into here. So when I plug all this into the rest of the stuff in here, that's when we start to get something wonky happening up front. So essentially what I'm going to do is, I think I'm going to grab a tap off the back of that thing and see if I can hardwire the depth finder up front, that wire. See if I can hardwire that directly into the back of this. I would like it to have a switch on it. Might see if there's a way, maybe I can do this a different way where I can put a switch on it. But I mean, the depth finder has a switch on it as well. The only thing I don't like, again, is I don't like having constant power up there on those feeds. So I'm going to think about this one for a second. I'll come up with a plan, and I'll be right back. But we did confirm, at least to the best that I can confirm without, cutting a hole in the boat to see what the wire looks like, that this pin in this plug is the home run back to the battery over there. So now that we got that, and now we've measured the resistance drop across it, and it's practically zero, we're going to devise a plan. So stay tuned. I'll be right back. Good afternoon. Welcome back. It is the next day. I thought we had this licked yesterday, but unfortunately, this morning had the issue again. And this is going back to the boat stuff here. So, oh, hello there, Mr. Wasp. If he comes over here, you're going to see an interesting scenario unfold. But anyway, so let me show you what we got going on here. So last night, I boiled the battery in this thing to make sure it was fully charged. And oh, looks like my cable came off of here. One second. All right. So it's had some time to mellow out, but basically we were showing about 13.3, 13.4 when I took the charger off of it. Right now it's at 12.96 on the battery. And so over here at the depth finder, we've got 12.0. So we're back to another 0.9 of a volt drop across this entire wire. Whereas last night, when I was done with it, I actually had this thing up and powered for a good solid hour and 15 minutes while I was cleaning up. And all the wiring was back to normal. I only had like a 0.2 volt drop, which is acceptable. No issues. There's still something going on with the wiring in here. Not sure what it is. I think part of the problem is that thing is also overly sensitive to voltage drop, but I shouldn't also have that big of a gap in voltage drop. So what we're going to do today is I'm going to try to pull a home run wire through the hull on this thing. I've got my fish tape that we're going to try to use. I'm going to try to pull a home run through to the battery, hook it up with the same fuse that I have on this circuit right now, and then remember I was saying yesterday that, I'm sorry, my chain's getting caught on my microphone here. How's it sound? Remember I was saying yesterday that I didn't like having constant power up there, and I really don't want to drill and put a separate switch in just for that. So what I thought about this morning is I'm actually going to wire a relay in line in there, and I'll show you how I'm going to do this. But basically, I'm going to run a home run power cable from the battery to the relay. It'll feed home run power to the depth finder up there, and then I'll have the relay activated with the same switch in the dash that currently activates this thing. So essentially all we're doing is, instead of the switch power directly powering the depth finder, the switch power is going to trigger the relay, which will send direct current all the way through. So that's the plan. Question is, do I have enough wire to do it? I think I do, using my wire thing that I was using yesterday with different crimp connectors and everything like that. So sorry, I got sunglasses on. It's extremely bright out here today and much warmer. Oh yeah, well, I already talked about the weather at the beginning of this video, so I won't go back into it. It's nice out today. So I'm going to go get busy getting everything prepared. I got to pull a wire back down under the dash, disconnect everything, and see if I can pull the fish tape all the way through the hull without getting caught. That's the neater way to do it. I mean, yeah, I could run it up along the side next to another wire that's already running back there, but kind of OCD on that thing. So if I can get the wire through the hull, that's what I'm going to do. So anyway, stand by. I'll be back in a few minutes when I get to the next break-even point, next update point. But stand by. We're going to get this thing sorted out one way, shape, or form. Be right back. All right, so we have got some updates here. I have successfully pulled the wire through the hull on the boat here. So going from front to back, we've got right here. So I've got this. This is the original wire that was already running. I went ahead and fished that into the hull, and that goes all the way up along here and then pops out right up under there, right? I take that back. I'm sorry. It's not the original. That's that long wire that I had. That pops out under here. Try to get this the right orientation. But anyway, that pops out right here and then continues on through the hull and comes out back here. And I went ahead and put the fuse holder on there. Everything's ready to go. So the ground will be tied directly to the battery. The fuse holder will be tied directly to the battery. And then that same ground is going to power and trigger the relay as well. It's going to trigger the relay. The power is going to come from the switch in the dash here. But the ground for the ground side of the relay is going to come off of that ground. And then, of course, like I said, the power is going to feed all the way through. Let me go grab a relay, and I'll explain to you how the relay is actually going to work. Stand by. All right, so this little jobby is a 12-volt relay. As you can see, it says 12 volt, 20 amp, 30 amp, and then it's got a little pinout that shows you exactly how it works. And so what each of those numbers corresponds to is pins on the bottom of the relay. So what a relay does is, when you apply power and ground to these two poles, it forces a magnetic field inside the relay, which then closes two contacts, right? That's these three across the bottom here. When the relay is in normally closed position, which it is, it's not energized, this vertical pole and this horizontal pole are connected. So if you want something to power through the relay when the relay is not energized, those are the two poles you would connect it to. When you energize the relay and you get that click, right, you 12 volt here, ground there, vice versa, whatever, that now connects this vertical pole and this horizontal pole. So that's essentially what we're going to do with this relay. We're going to use the wire that I ran. The 12 volt signal coming off the battery is going to go into this pole right here. Okay. The ground is going to go to one of these two poles. And then it's also going to continue on up to the depth finder to ground that. I'll have 12 volts from the switch on the panel here on this side. So when I flip that switch on, it applies 12 volts. It'll have ground here. This vertical pole and this bottom horizontal pole will then connect. Coming off of this pole will be the continuation of that 12 volt feed to go up to the depth finder. So as you can see, what this does is it takes the switch out of the equation for having to pass the power directly to the depth finder. Instead, it energizes the relay only, which is very low current, requires very low voltage to trigger a relay. And then that direct 12 volt current from the battery will pass through the relay and subsequently up onto the depth finder. So that's what we're going to do next. We're going to install this relay and get that all wired in, so then we can connect it up to the battery and then test that we have 12 volts up front. So let me get that going and I'll be right back. All right, welcome back. We are about to test this thing now. So let me show you what I've got here, and hopefully you can see it. So we got 12.9 volts on the battery. I've got my fuse holder wired in here, ground strap, 12 volt signal connected to the battery in here, again running way up under there. We got 12.9 volts. We've got, let me see if I can get this thing down here so you guys can see this. We have our relay wired in down there, which is not focusing. We've got our relay right here, which I will tape up as well. Thank you, Mr. Helicopter. Oh, that thing is loud. Anyway, so again, 12 volt signal coming in, 12 volt signal going out once it's switched on. Got our ground wire on this side, and then the 12 volt switch from the power switch here. So when I turn this on, relay clicks, and we have 13 volts up here. So this is actually a voltage amplifying relay. So it takes low voltage from the back and it makes it more voltage up front. No, that's not really the case. That's just discrepancy in the 2 meters. You know, these are obviously highly calibrated, extremely expensive Harbor Freight voltmeters here. So there's going to be some discrepancy in these things. But like I said, we've got our wires here, 13 volts. If I flip the switch off over here, we should see nothing. And that's what we got. So now I need to hook up the depth finder, and then I'll do the voltage draw on it, and we'll see what happens once it's connected, since that thing apparently draws a boatload of power. No pun intended. So I'll be right back. Y'all don't go nowhere. Okay. So as you can see, we have, let's see here, 13.12 volts. Now we're going to go ahead and power this thing on and watch the voltage drop considerably. Learned a lot about this little depth finder just in my research that I was doing here. Pretty neat little device, actually. They only have about 6,700 different variations of this, well, of depth finders at Lowrance, or Lowrance, or however you pronounce it. Sounds kind of valley-ish, right? Hello, Lowrance. But anyway. All right. No, we're not going to register. Now, there we go. And we're going to watch the voltage. Let's see. So we got 12.82 up here, which is considerably higher than what we had in the back. Well, had earlier. And we've got 12.8 over here. So they're actually equal now. Looky there. So, birds are talking. Anyway, I'm going to go ahead and let this sit for a while. Make sure it's good. And in the meantime, I'm going to strap up this other cable too. My dad has a trigger switch under here. Not that. He has a trigger switch under here. This is a runaway trim motor switch. There's another intermittent problem with this thing, that sometimes the trim motor will just keep on going, and so that thing actually disconnects it. I went ahead and ran that through the galley as well to the back. Galley, not the kitchen, but maybe the valley inside here. I ran it along with the other wire, since it was basically running up along the side here. Kill 2 birds with 1 stone. But anyway, let me let this sit for a while, and we'll see what happens. So I'll be back. Don't go anywhere. All right. So we've been having this thing sitting here for about an hour or so, and not much of a voltage drop so far. I'm going to go ahead and button all this up here in a second, but 12.7, 12.75 right there, and still showing 12.74 on the battery. So just about exactly equal. Now, of course, if I shut the power off on that switch, well, then I won't have any power up front. Now, will I? Dang, that's science. Anyway, I think this is going to take care of it. So, again, another lesson. I know, DIY is it's a tricky thing sometimes, but like I've always said, if you take your time, work your way through, there's nothing you can't figure out, there's nothing you can't fix. And by doing it yourself, now you have a grave understanding, or better understanding of exactly how everything works. I mean, going through this entire process here, I'm pretty much know every wire in this boat now, where it is. I didn't know that before. But I hope this was a good learning tutorial for everybody on how to troubleshoot 12-volt circuits. You can do this with any electrical circuit, really. Start at the destination, work your way back, test each individual line. Anywhere that there is a connection made in the line, in other words, the line was broken and connected either through a switch, through a connector, a twist on, a butt connector, whatever, separate it, test it from end to end, make sure that part is good, and then move on down the line. And you want to do that on both sides. Obviously, circuits take at least two wires to connect. You got a hot source and you got a ground source. So test both sides, make sure. And then, hey, sometimes, like we see right here, sometimes even after you do all your due diligence in there and you test all the wires and everything looks good, test and retest. Okay, if I'd have just sat on it last night and said, hey, it's fixed, I'd have brought it back to my dad. First time he'd have taken it out, thing would have been going nuts again. So again, another way to also fix. I mean, this is a fairly basic circuit. It's nothing special. 12-volt switch and everything like that. The wire's old in this thing. Like I said, it's a 96 model. It wasn't real hard to run a cable all the way through to the battery, break it, put a relay in line, everything like that. And, for a fairly short amount of time, we were able to fix it. I could have done that at first and really saved myself a lot of time, but part of DIY is investing the time to try to figure out what's wrong with the actual original equipment, right? What's wrong with the original wiring? Because I'll tell you this, and it's the last thing I'll say, if there's an issue on one circuit, chances are there's probably a residual issue on other circuits. So spend the time, try to figure it out. It worked before, should work again. My dad told me this morning when I was talking to him that his old depth finder used to lose voltage too. So apparently this has been an ongoing problem for quite a long time I was unaware of. But anyway, again, I hope this was a very good learning experience. I'm glad to finally be able to do another video in some nice weather, and I hope you guys enjoy it. Click subscribe down there. Subscribe to this, and it's free, doesn't cost anything. If you like the videos, click the notification bell. You'll get an alert whenever I put out new content. Again, as time permits, I'm going to do it. We're just kicking off ball season with my daughter, so things are going to get real busy, even busier than they have been. But I'll continue to try to put some stuff out as soon as I can. Got some good projects coming up. That C10 sitting back there that you guys probably saw in the shot and saw my other videos. Got some big stuff coming for that thing as well. So in the next few months. So stay tuned for that. Stay tuned for more DIY stuff. And once again, thank you all for your support. Excuse me. Thank you all for all the comments and everything. Can't do this without you. You guys rock. This is DIY 1978 guy telling you. Peace.